next unit in the basic soil science class is on soil pH, or the degree of acidity or alkalinity in a soil. Soil pH can be defined as the concentration of hydrogen ions that are in solution in that soil at a given point in time. But really it's more than just the concentration of hydrogen, it is also the concentration of hydrogen in relationship to the concentration of hydroxide. There are several ions that are involved in determination of soil pH, but those that are most directly influencing the pH of the soil are the hydrogen and the hydroxide ion contents. The hydrogen ion promotes acidity in the soil, whereas the hydroxide, the OH ion, promotes basicity or alkalinity in the soil. When we are measuring the pH of a soil, we actually measure the concentration of hydrogen ions that are in solution at that one point in time. However, we need to understand that the concentration of hydrogen ions are in an equilibrium with the concentration of hydroxide ions. Much like the equilibrium we previously discussed on cation exchange, the equilibrium between hydrogen and hydroxide ions in the soil solution is a very similar process. That is to say, if we increase the concentration of hydrogen ions, it will be at the expense of the hydroxide ions. The reverse of this would also be true. If we increase hydroxide ion concentration, then we would see a corresponding decrease in the concentration of hydrogen ions. pH of a soil, like pH of any other type of substance or material, is measured with a pH scale. And that pH scale numerically runs from 0 through 14. Now, all of the cations that we previously talked about in our discussion of cation exchange are either listed as being acidic cations or basic cations. And they're listed as being acidic or basic based upon their influence upon the pH of a soil. Those acidic ions were hydrogen and aluminum, you'll recall, and the basic ions were calcium, magnesium, potassium, ammonium, and sodium. So what I'm really saying now is that as we increase the concentration of the basic cations, we would expect the soil pH to be higher or above neutral on the scale, and as we decrease the concentration of those cations, we would expect the pH to go down or further into the acidic side of the pH scale. The next thing we need to do is to look at this pH scale and where soils might fall on this scale and what it means if a soil has a pH within a certain value or numerical range on that scale. Just before we do that, though, I would like to make one other comment, and that is that if we have a soil that is considered to be neutral, that is to say that the pH of this soil is 7, or numerically in the middle of the scale, then we have an equal concentration of hydrogen cations and hydroxide ions in solution. As we progress down the scale or become more acidic, the concentration of hydrogen ions will increase at the expense of the concentration of hydroxide ions. The reverse would be true if we went up the scale to a larger number. That is an increase in the hydroxide ion content at the expense of the hydrogen ion concentration. And in all cases when we're talking about pH, we're talking about the concentration of these that occur in the aqueous phase of the soil or in the soil solution.